In this video, I'm going to introduce you to a type of functions called anonymous functions. They are closely related to something else called inline functions, but I'm going to be focusing on anonymous functions. The idea of an anonymous function is that it's a function that can be written out basically in just one line of code, so it doesn't need a separate file. It looks like a variable. It's a handle object. You'll see that in a moment. Anonymous functions are used quite often in model fitting and optimization. They're actually not so frequently used in signal processing and data analysis, although you probably will come across anonymous functions as you continue through your adventures in Matlab. So I'm going to show you how to understand and create anonymous functions, and at the end of the video I will show you a quick example of using anonymous functions to solve optimization problem. An anonymous function is a little bit weird looking at first. It takes a little bit of getting used to. So the general form of an anonymous function is you start with the variable name, the function name, which is actually a handle to a function object, and then you have an @ symbol here, and then the input into the function, and then the actual function itself. So you can see that the whole function basically needs to fit on one line. If you have a function that takes multiple lines of code, and then it's probably better to just define it as its own function in a separate file. Okay, so here is an example. I have a function. I'm going to create an anonymous function called myfunc equals the @ symbol, so that tells Matlab that we're going to create an anonymous function. The input is x, and the function is x squared. Okay, so let's run this line of code. Notice, by the way, let me type whos. I just want to show you that there is no variable x. I haven't created a variable x. And yet, Matlab doesn't give any errors or warnings, even though we are trying to use x. So Matlab knows that x is just like a placeholder for the input into this function. Okay, so now we can type whos again, and we see that this variable, myfunc, is of class function handles. That's a different category of variables from what you've seen so far in this course. So, and then we can dump this out and see what it looks like. So myfunc is a function handle with value at x squared. So this is the input into the function, and this is the body of the function. Now, myfunc is actually not a very useful name for a function, because it doesn't really tell you any useful information. It tells you that, it's mine, it's my function, but it's not very informative. I think a better function name for something like this would be something like x2 fun. So x2 for x squared, and fun both because it's a function and because anonymous functions are tons of fun. Aren't you having fun so far? Okay, but when you are creating anonymous functions, it's a good idea to give them some kind of a useful name and end it in fun or func or something that will tell you that this is not a regular variable. It's not a matrix or a vector or a string or a cell array. It is a function. All right, so now to use this function, you basically treat this function, this anonymous function, as if it were a normal function that we've been working with throughout the course so far. So it's always a good idea to test functions when you know the answer. So I'm going to input 0, and I know that 0 squared should be 0. So run that, we get 0. 2 squared is 4, so we should get the answer of 4. And 4 squared is, what is it, 19.7 something? It's 16. I was close. All right, let's see. Here's an interesting question. Does this anonymous function, or do anonymous functions in general, work on vector inputs, or do they only work on scalar inputs? Because I'm only specifying one input here. So we can try this. Now it turns out that the problem here is not with an anonymous function. The problem is with using the way that I've implemented this caret symbol, the power operator over here. What we need to do is element-wise power, and so we want to use dot caret. So the dot in Matlab is always reserved for element-wise operations. So now I'm going to redefine this function, which is really easy. I just run this line of code again, and that redefines the function. And then run this line of code again, and then we get 1, 2, 3 is the input, and the output is 1, 4, 9. So 1 squared, 2 squared, and 3 squared. Okay, so this is pretty neat using vector inputs because that allows us to use this anonymous function in more flexible ways. So I can define some x value here to go from -3 to +3, and then I'm going to plot x by the output of this function, x2 fun. So here we get a plot of x by x squared over here. And now the reason why I chose x here was also to show you that you can set different variables here for this variable x we have in the workspace, and this variable x that I'm inputting, or that becomes the output of this function here. Now, this actually can get a little bit confusing, and in a few moments, I'm going to show you an example of how this can get confusing by having variables in the workspace that are the same as the variables inside the anonymous function. Okay, but first, before getting to that, I want to show you how to define anonymous inputs with or anonymous functions with multiple inputs. This line of code here is just showing that you can save the output of this anonymous function. So this is just another illustration that once you create an anonymous function, you can interact with it as if it were a regular function in a separate file. Okay, so multiple inputs is really straightforward. So it's essentially the same format. We still have the @ symbol to tell Matlab that we are creating an anonymous function. And then you have in parentheses the first input, comma, the second input. And then here's the function, which in this case is x squared plus y. So again, this is really, really similar to how you would create a normal function in a separate file, a separate Matlab M script. It's just that we're condensing everything into one line of code here. Well, and another key difference, of course, is that this function only exists inside the Matlab workspace. As soon as I, clear out the Matlab workspace or close the Matlab session and open up a new session, I no longer have access to this function x squared with offset. That's what that stands for. Okay, and again, it's always good to test with known outputs first. So this gives us 9, which is expected because that should be 3 squared plus 0. So we can try this with 1, and then we get 10. We can try this with 10, and then we get 19, because this is 3 squared plus 10. Now, having two inputs is pretty neat, because here we could generate a plot. It's just a one-dimensional plot, because we can just produce a line with one, or a curve with one variable input. Now we have two inputs, so we can actually make a grid. We can make an image. So I'm going to create a grid of x, y values using the mesh grid function. I've introduced you to this before. I think it was in the video on creating images from matrices in the section on visualization. So now I'm actually inputting matrices, matrix x and matrix y, into this function. And that gives us this output matrix z. And then we can make an image of that output matrix. So that looks like this. So this is pretty neat. We see the value of the function. So let me make sure that this is crystal clear. So here I ran this function with inputs x equals 3 and y equals 1, and the output was z equals 10. So now on this image, we look for x equals 3, that's over here, y equals 1, that's over here. So the value of this pixel right here is 10. I'm even going to put a color bar to make sure that that's clear. So each pixel in this image corresponds to a color which maps onto the value of this function, x squared plus y, for all possible, or not all possible, but these possible input values of x and these input values of y. Okay, and then up here in the title, I have used a function called func2string. So the func2string function is going to take an anonymous function and basically just convert the function into a string. So we can see the input to the function and the function definition. All right, so this is an image, and yeah, if you like, you can also make a plot showing all these lines. Not super duper interesting. Maybe if we flip it, it's going to look a little bit happier. Doesn't this look happy? This looks like a lot of smiles here. Okay, so there's two more things that I would like to get to in this video. One is a common error that can happen with anonymous functions. So I'm going to clear the workspace, so we have an empty workspace, define this function. Now notice this function, this is something that would be really easy to do by accident. This could be an honest mistake. The input variable is x, but notice that the input variable doesn't actually appear in the function definition itself. So there's no x that appears here. So let's see what's going to happen when we input 0, for example. What might we expect here? Well, we get an error, and the error message is unrecognized function or variable y. So that's actually good. This is an error that we would like to see. We inputted x, and the function doesn't have x anywhere, but it does have y, and we didn't input y. Okay, and now what I'm going to do is define a variable y in the workspace, but not input it into the function. So now I'm going to run this function again, and we still get this the same error message. So actually, let's see, this is, yeah, okay, so there it went. So now I redefined y, and then I redefined this function over here. So let's see, so here was how it all shook out. So I created this function where y did not exist in the Matlab workspace, and then we got an error message here saying that y doesn't exist. Then I created this variable y in the workspace, and then I had to redefine the function. But now, when I redefine the function, y actually does exist. Y isn't defined inside the function itself, and it's not provided as an input, but y does exist in the workspace. So Matlab actually took the value of y from the workspace and put that into the function. And now we can run this function again, specifying x to be equal to 0, but that doesn't even appear in the function. And the output of this function was now 9, which is y squared when y is equal to 3. All right, so you can see this is pretty confusing behavior. Furthermore, this behavior is actually Matlab version dependent. It will either give an answer like what you just saw here, or Matlab will continue giving an error. I believe in older versions of Matlab, you would still get an error. Matlab wouldn't really like this behavior that you can specify the variable in the workspace. The point is, you have to be really careful when you are defining these functions that the variables are consistent. Otherwise, it can lead to confusion. Okay, so now the final thing I want to show you in this video is an example of using anonymous functions to solve minimization problems. Minimization problems are, you might recognize them from calculus. You might have studied some minimization problems. They come up really often in engineering and in finance and computational biology. Minimization problems come up quite a lot. Definitely they come up all the time in machine learning and AI and deep learning and so on. Okay, so there are entire courses, there are huge volumes of books that are just about minimization problems. So I'm not really going to talk a lot about the concepts or the math or the implementation of minimization. It's just going to be one really simple example. I just want to give you a flavor of how anonymous functions are used. Okay, so here's an anonymous function. It's a function of one variable. I'm calling it t. And here I call it x, but that's just in the comment. So here I say t. The function itself is t cubed plus t to the 4th power. So the question is, what is a value that minimizes this function around some point, or maybe the global minimum? So t cubed is a function that starts off at minus infinity and it comes down. It has a dip and then it goes back up to plus infinity. And t to the 4th looks like t squared, except it's more narrow. So that looks like this. So when you add these together, it's basically going to come down. It looks a little bit like, kind of a parabola like t squared, but it's going to do something funny close to the origin. Okay, so here's a question for you. Which sets of parentheses are optional in this line of code? I will let you discover that on your own. Okay, so I call this function x3 plus x4, and maybe it would have been better to call this fun like this, and I think I'll actually do that. By the way, what I did there to replace all of these variables was I changed one variable name, and Matlab gave me a message here. It says press Shift plus Enter to rename the other 3 instances everywhere else in this script from the original variable to what I just changed it to. So that's a little keyboard shortcut. Okay, so now I have to redefine this function. Let's see, and I'm going to evaluate this function for x from, or t, from -3 to +3. You can see I'm also using a different variable name here compared to what I define here. That is no problem. Okay, so this is what, actually let me show you the zoomed out version. This is what the function looks like, t cubed plus t to the 4th power. And these numbers are getting pretty large, so I'm just zooming in on the y-axis here just so you can see that it kind of dips down and then it goes up, and then there's maybe a little bit of dip or at least a shoulder, and then it goes up again. Okay, and now I'm going to use a function called fminSearch. This is a function that will search through another function that you input for a minimum of that function, and it's a minimum near a point. So this is the starting point. So we input a function into this function, or a function handle into this function, and we input a starting point. And fminSearch is basically going to look around this function and try to find the minimum around this, this starting value. And we are going to request 2 outputs, the minimum value of x and the minimum value of y. So that's basically the function value and the location where that function has its minimum. So you can see that this is an optimization problem. It's a minimization problem. Given some mathematical function, we find the minimum near some point. Okay, and then I'm going to plot a dot over here. So that is the minimum of the function t cubed plus t to the 4th. Very nice. I hope you enjoyed this video. You learned about anonymous functions and working with anonymous functions, and a little bit, a little taste of how anonymous functions are used to solve optimization problems in Matlab.